Alright, you guys, we're in Chapter 10, Section 4, and we are looking at ellipses. Now, our objectives here are to write the equation of an ellipse and to find the foci of an ellipse. Alright, so let's begin with vocab. There's a lot of new words that we're going to see in this section. Now, an ellipse, this is the set of all points P in a plane such that the sum of the distances from P to two fixed points f sub 1 and f sub 2 is a constant k. Now this might not make a lot of sense at first, but let's go ahead and write it down and we'll come back and look at this. So an ellipse is the set of all points P in a plane such that the sum of the distances from P to two fixed points f sub 1 and f sub 2 is a constant, and we'll call that constant k. Now a focus of an ellipse, and the plural way to say that is foci, this is one of the two fixed points. Now our symbols here show us that our distance from a point to one focus plus the distance from another point, the same point to the other focus. So the sum of those two distances from the same point to one focus and the same point to another focus is equal to k. Last, an ellipse stretches a circle in one direction and is a set of points that have a total fixed distance from 2 points. So we're filling this in with an ellipse. It stretches a circle in one direction and is a set of points that have a total fixed distance from 2 points. Alright, so let's go ahead and sketch these pictures if you didn't print up the guided notes, and let's fill in the blanks here. So we have some more vocab. We're looking, first of all, point out that we're looking at two different types of ellipses. We have a horizontal one and we have a vertical ellipse. Now, we're going to have the same vocab for each, just notice how they're different. So, we have a major axis, which is a segment that contains the foci and has its endpoints on the ellipse. So our foci are F1 and F2. So here's our major axis here. And our foci for the vertical ellipse are here and here. So here's our major axis. So we're going to go ahead and label these. So in this box I'm going to say major axis, or major axis, and major axis. Alright. Now its midpoint, the midpoint of the major axis, is the center of the ellipse. So here's our center, and here's our center. The minor axis is perpendicular to the major axis at the center. So this is our minor, it's perpendicular to the major, and here's our minor for the horizontal. And lastly, we have the vertices of an ellipse, which are the endpoints of the major axis. So, if our major axis for our horizontal is this one, then the endpoints, our vertices, are right here. And the co-vertices of an ellipse are the endpoints of the minor axis. So here's our minor axis, and here's our endpoints. So we have vertices, which go along with the major. And here our vertices are right here. And then we have the co-vertices. Plural, it would just be co-vertex. So I'll make it, I'm sorry, not plural, singular. So co-vertex. Okay, so make sure you get this down. This is also in our book on page 639 if you want to look it up online for your online textbook. Alright, so now let's look at the standard equation of an ellipse with center 0, 0. Now first I want to change to the right here. Go ahead and make this change for me. This should be b squared. And this b squared we're going to change to a squared. So we just flipped it around. Okay, and now what we're going to write also is going to go along with the chart that we just looked at. So the first one we're going to talk about is a horizontal ellipse. And here's our standard equation. So we have x squared over a squared plus y squared over b squared is equal to 1. Our vertices, again, this is going to align with the picture that we just saw. Our vertices will be at a, 0, and negative a, 0. Now our co-vertices, those, since they're on the minor axis, will be at 0, b, and 0, negative b. And our foci are going to be at c, 0, and negative c, 0. Oh, that's kind of ugly. Here we go. So negative c, 0. Okay, and now looking at our vertical ellipses, the standard form for this is x squared over b squared plus y squared over a squared is equal to 1. Our vertices here, again looking back at the diagram before, our vertice here is going to be at 0a and 0, negative a. Our co-vertices are going to be at b, 0, and negative b, 0. And the foci are at 0, c, and 0, negative c. Alright, so let's write an equation of an ellipse. It says, what is an equation in standard form of an ellipse centered at the origin with vertex negative 6, 0 and co-vertex 0, 3? Alright, well since we know that one vertex is at negative 6, 0, then we know another vertex is at positive 6, 0. It tells us we have a co-vertex at 0, 3, which means we'll also have another co-vertex at 0, negative 3. With our vertex being at negative 6, 0, this tells us that our major axis is horizontal. So we are working with a horizontal ellipse. So we're going to look over here. In order to write our equation, we need to figure out what a squared is and what b squared is. The vertex is negative 6, 0, and I know that negative 6 represents my a value. So I can say a is equal to negative 6. I also know since my co-vertex is at 0, 3, and looking up here for co-vertices, I see that my b is going to be 3. So now I just plug this in. So x squared over negative 6 squared plus y squared over 3 squared is equal to 1. And then simplifying, I get x squared over 36 plus y squared over 9 is equal to 1. And now I have my standard form of an ellipse centered at the origin. Alright, so you try. What is the equation in standard form of an ellipse centered at the origin with vertex 0, 5 and co-vertex 2, 0? First, you need to decide if this is going to be a horizontal ellipse or a vertical ellipse. And once you've decided that, just identify your A and your B. Notice over here again we changed it. So B goes under x squared and A goes under y squared. Once you identify your A and your B, then you can just go ahead and substitute it in and write your standard form.